Welcome to our live web event today discussing how SDN simplifies the complexity of enabling real-time multimedia deployments and how it automates collaboration experiences. We're expecting this session to be about an hour, and the session is being recorded. You'll be placed on mute until the Q&A session a little later on, and at that point your microphones will be unmuted and you'll be able to ask questions live of our panelists. I'm Jim Burton, co-founder of UC Strategies, and my main business is CT Link. And I'm joined today by Manfred Arndt from HP, who is a distinguished technologist, Chris Lauer from Ubiquiti, Manny from Polycom, Shambo Rai from Sonus, and John Snyder from Cisco. We're going to get started with Chris, and Chris, I have a question for you to get started. What is RTM SDN and what problems does it solve?
Well, Jim, in a nutshell, RTM SDN is about the use of SDN, software-defined networking, to optimize the quality of experience delivered by real-time media applications. And by real-time media applications, we mean any application where the real-time or almost instantaneous delivery of the media or of the information associated with those applications matters. So typically, those are things like voice and video applications such as voice over IP or unified communications that may include a video component or a video conferencing application. But it may also include things like virtual desktop infrastructure where you access your desktop remotely across a network rather than locally on a machine in front of which you're sitting. So in those kinds of environments, the delivery of the voice and video components or of the screen components that you're watching need to be delivered across a network in almost real time for the application to be very useful. And those types of applications have gained tremendously in importance over the last 5 or 10 years or so because they've enabled collaboration well beyond what was previously possible. And so that has allowed companies and enterprises to build remote teams, to build virtual teams where people are no longer in the same location. It has allowed telecommuting. It has allowed globalization of how people work together. So these applications have been tremendously important over the last 5 or 10 years. For these real-time media applications to enable those types of use cases, it is critical that the quality of the experience that gets delivered to the end user is of sufficiently high quality. And I think we've all been in front of a video application where you see pixelated video, or we've had voice over IP experiences where there's been voice artifacts or echo or perhaps drops in audio altogether. So in practice, these real-time media applications really haven't been perfect. And what's interesting is that if you start looking at the causes or the root causes of what causes these experience or these quality problems, 60 to 80% of the time, it's actually the underlying network that is the cause of those quality problems. This can happen when there's congestion in the network, which causes packets to be lost, or when there's congestion that results in packets being delivered late, which for real-time applications is almost equivalent to the packets being dropped. With newer technologies, when you start delivering real-time media over wireless networks introduce a whole new class of problems in terms of interference and those kinds of things that can contribute to the quality problems. So being able to get access to the underlying network to get to the root cause of a problem has been challenging for people who deliver real-time applications. And so as we start thinking about, well, what can we do about that? It turns out that it's actually quite difficult for the developers or the vendors of the real-time media applications to do something directly about problems with the underlying network, because historically there haven't really been any interfaces into the network that an application developer can take advantage of to go look into the network to see what's going on, let alone to take corrective action. So people historically have been reduced to things like error concealment, and error correction in terms of, in order to try to optimize the quality. And those have been limited in terms of success. But then when SDN came around, software-defined networking then finally created an opportunity for application developers to go interact directly with the network. And that allows real-time media applications to close the loop, if you will, between the application layer and the underlying networking layer. So SDN allows the application developer, the developer of the real-time media applications, to tell the network how it would like the media to be treated on the network, and vice versa. It allows the application developer to get information from the network about how the traffic is being treated, what the quality is of the transmission, and what have you. So that kind of interaction allows a closed loop system that finally gives us an opportunity to, in an automated fashion, optimize the quality of the experience that's being delivered to the end user. So that SDN opportunity caused us in the IMTC to start a couple work items around what we now call RTM SDN, which is the use of SDN to optimize quality of experience. And we've been engaged in three phases of work so far. In the first phase, we focused on what we call automating the quality of experience, and we did that by automating QoS marking, where the application tells the network what kind of QoS markings the network should associate with the media traffic that's being put on the network. And so that allows network administrators to get out of the business of having to set up in a statically predefined fashion things like QoS, where you use things like application recognition in the network to figure out, well, which packets are voice, which packets are video, mark them appropriately, and hope that they get treated the right way based on that process. So network administrators can get out of the business of having to set these things up statically, and instead the application will inform the network in a dynamic fashion how the packets should get marked with the appropriate QoS markings. A second aspect of that is to also then automate traffic engineering. And by traffic engineering, we mean two things. We mean the allocation of certain amounts of bandwidth to specific types of traffic or to specific classes of media. So you could instruct the network to set aside a certain amount of traffic for voice, a certain amount of bandwidth for video, and do that in an automated fashion based on anticipated traffic patterns in your UC or RTM applications. And then finally, we also automated, call it mission control, where if there is no longer sufficient bandwidth available in the network to let new media or new flows on the network, will inform the application, and the application can then send a busy signal back to the end user. And again, do this in an all fully automated fashion. So that was the first work item we engaged in. The second work item had to do with diagnostics, where we use SDN to retrieve information from the network about what's actually going on with the media streams that are being transmitted. And we do this by directing the network to monitor the specific network elements through which the media are flowing, and changing the granularity of the monitoring information so that we can correlate it with actual call traffic. And then the second part of that is to let applications, the RTM applications themselves, communicate their perspective of the quality with the underlying network, so the network can correlate network-specific information with endpoint-specific information or application-specific information, and hopefully get a better understanding of what's at the root of some of the quality problems that we may be experiencing. And then the third work item we're engaged in is to take these concepts of automated quality of experience and automated diagnostics, but apply them to cloud environments, which introduces a whole new set of challenges. And that's what really the topic of this webinar is about, and that we'll talk about in more detail during the rest of the hour.
Well, Chris, thank you a lot. I thought you did a great job of laying the groundwork to get us started here, which kind of takes us to the next step. And John, I'd like to ask you, So what are the trends in our industry that are driving the increased demand for cloud-delivered solutions?
Thanks, Jim. It's a good question, and obviously on the minds of customers that are looking at what they should do in the future with their collaboration infrastructure. And what we really see today is that everybody sees benefits and yet has concerns with having their collaboration infrastructure inside their network and on-premise. So they see the benefits, obviously, of doing that. It's, first of all, what they're comfortable with and what they've been doing for a very long time. So it's what everybody knows. They don't have a reliance on a cloud service provider, so it's in their hands whether they upgrade, when they upgrade, what features they enable and disable, and the operation of the system is something that they control. And also importantly is that the data and the media, all of the artifacts of the collaboration stay within the boundaries of their enterprise. And so whatever encryption standards they have, whatever firewall policies and security policies they have, and they're able to kind of keep those things there. So they're not so, worried about them falling into someone else's hands or being stored in a cloud service provider that may have a data breach and those sorts of issues. But of course, with those advantages or perceived advantages come a set of concerns, and some of those concerns are around complexity and lack of skills for the staff. So needing to have people that are up to speed on managing the collaboration environment and the network that supports it, the operational complexity of all of the different pieces working together, especially when it comes time for an upgrade, and what impact that might have on the end users, especially if the clients are changing. Those can be an issue. It can also take a lot of time and potentially cost a lot of money to upgrade a collaboration environment that's hosted on-prem because the different components might need professional services to be involved in order to upgrade them properly. And then, you, of course, have inconsistent spending cycles. So instead of maybe a per user per month charge like you might have with a cloud service, you may have years go by with little expenditure, and then the need for an upgrade or a forklift into a new environment can cause a large capital outlay. So some of those things are what's on people's minds when it comes to the trends in the industry and on-prem collaboration. Now, if we move on to the next slide and we talk about some of the concerns and benefits with cloud collaboration, obviously what everybody wants is to have the best of both worlds, right? They want to get rid of the concerns and yet have the benefits of cloud and on-prem and have the best of both. So some of the concerns that we see a lot of customers have with cloud offerings are stability, quality, and security. So when they look at those things, they think about, okay, I could consume my collaboration from the cloud, and I would have the advantage of being able to have a predictable spending model and paying as I go. I don't have to worry about training my staff to upgrade the solution and operate it. The cloud provider will do that for me and be able to deliver features very quickly. And yet I have these concerns about the fact that I'm letting go of some element of control. So all of a sudden, instead of me controlling when things get upgraded, whether it's up or down, and being responsible for it, the cloud provider is now responsible for that. So that's good on the one hand because I don't have to deal with it. But then, of course, whenever it's not working the way I want it to, that's a problem. Security, of course, is a concern, more so with cloud offerings than with on-prem offerings because your data, in many cases, is being stored somewhere else, and the security of that data is the responsibility of someone else. So if there are issues or problems or a data breach, then you may be exposed. So people are worried about that. The one that we're really going to focus on, though, today, and one of the concerns that customers often have with cloud collaboration that we think RTM SDN can help with is regards to the quality of the actual real-time collaboration sessions. So whether that's an audio conference or a real-time video conference, a lot of times people associate cloud-based collaboration offerings with a decrease in quality because that media is being sent over networks that they may not have as much control over as their on-prem data network. So when we think about RTM SDN, we want to be able to provide the benefits of those cloud-based offerings without having to have so much of a concern around the quality of the media. And so we're going to talk today about how that's possible, what some of these emerging technologies will do to allow customers to not only have high-quality collaboration, real-time media collaboration experiences, but also be able to guarantee and see that they, in fact, are not compromising quality when they move to the cloud.
Well, John, great job, by the way. I think that you did a very, very good job of laying out the challenges, the issues, and what the concerns are, and as well as the direction we want to go, which kind of brings us up to our next speaker. Manfred, can you explain the challenges with moving RTM SDN into the cloud and why the IMTC is creating a new use case specification?
Hi, Jim. Yes, thanks. Great question. So as Chris has highlighted earlier, the IMTC completed 2 prior specifications focused on on-premise UC and C deployments. This has been commercially released by a number of vendors across the industry. It's been shown to work well and is seeing strong interest by customers. We limited the scope initially intentionally to prove the concept works and to limit the complexity. However, as John has talked about, we were seeing strong interest in cloud-based UC and C deployments, and in addition to that, we're seeing other real-time applications now being deployed in the cloud, also seeing that the need of automating QE and providing a better user experience is something they want to do as well, given that we have shown that this can be done in a simple and automated manner. And that's why what we're doing is extending the specification for RTM SDN in the cloud. Now, for public cloud-based RTM deployments, they introduced some additional challenges that I want to talk about and that we'll cover in the rest of this webinar in a little bit more detail. So one is multiple domains. So a typical RTM deployment involves at least 3 different administrative domains. One is the enterprise customer domain. Another one is the public RTM service provider domain that hosts the applications in their data center, and then the public network provider domain. And the challenge is today people have very little visibility across these domains, and there is really no coordinations between them whatsoever. So we need some level of coordination between these domains and a way to provide some comprehensive visibility across them and ensure we can get a good QE experience in an automated and consistent and end-to-end fashion. The next item and a big challenge is the multi-tenancy. So in a public RTM deployment, the infrastructure as well as the network to deliver the services are shared across multiple enterprise customers and SMB customers. So this results in the need to support multi-tenancy, where multiple customers are sharing a single instance of the application or even sharing some of the common resources, including the network. This means the infrastructure, the RTM infrastructure, needs to allow the customers to optimize QE without negatively impacting each other, and even more importantly, providing visibility in a manner that doesn't compromise privacy or confidentiality. And then there's some additional security challenges. So, for example, enterprises typically deploy NAT firewalls to provide connectivity between networks and to do topology hiding. Well, this brings some additional challenges on how we can provide a consistent experience across end-to-end, because how do you map a given voice flow or video flow across the network when the addresses might even be changing? And then it's common for applications, SIP applications, to use things called ICE, interactive connectivity establishments, in conjunction with the SIP protocol to discover what the NAT firewall capabilities are. So there's some additional challenges that we're in the process of extending to the RTM SDN application. So what I want to walk through is talks about some of the use cases of what we're doing here and give a little example of what we're doing in this manner here. So here's an example. We have the service provider on the right, we've got the network service provider in the middle, and we have the enterprise on the left. And each one of these has their own SDN domain, and it's, they manage that separately, their network, and there really is no federation today between them. And long term, we do expect that to happen. But in this case, what we're doing is each one will discover and registers to the appropriate RTM application in the cloud, and they're using the red line there, which is the API. So when the user on the left initiates a call, in this case, we're initiating a call to, say, somebody on a SIP trunk on the very right in the RTM partners network. As that signaling is set up, the RTM application is aware of what is happening. So even when calls are encrypted, it has that information. And it'll send an appropriate create session call to the appropriate controllers, and then those controllers can apply the correct QoS policies. As you'll see in here is the AQS now can mark the policies correctly based on their domain, so they'll be able to push the right expedited forwarding for voice call or AF41, for example, if it's a video call, and then we can mark that QoS correctly for their domains based on what the RTM application has sent them as the flow parameters, or the end tuple for the flows. Another use case is admission control. In this case, let's say there's too many calls on the network. If that happens, a customer will only get an SLA from a server provider for so much video or voice. And unfortunately, when you exceed the SLA, it's not just the last call that suffers, every single call will suffer. So it's important that you protect existing calls, both within an enterprise and then both across enterprises. You don't want one enterprise impacting another. So in this case, the SDN application can be a bandwidth broker for the high priority traffic. We're not doing this for all applications, we're just doing it for the high priority applications. And then what we can do is we can either dynamically enforce bandwidth for high priority service by increasing the appropriate bandwidth dynamically, or what we can do is if we exceed some threshold, new calls can be marked at best effort or even blocked. So those policies are up to the individual SDN controllers or administrative policies that network administrators might want to set. Another use case is automated problem resolutions. And this is really a very powerful capability that we can provide, because today one of the hardest things is actually trying to figure out where the problem is. When you make a voice call, almost anything could be the endpoint, it could be a microphone in there, it could be the network, it could be improper QoS settings. So if the voice call is impacted, or you're seeing pixelation on the screen, where's that problem occurring? And this is hard enough within an enterprise. Now imagine when you're spanning multiple service providers and a cloud service provider, how do you figure out what's going on? Well, the RTM application typically today collects metrics from the endpoints. So in this example, the user on the far left is periodically sending through internal RTM application diagnostics collectors. Skype does this, Cisco WebEx does this, other applications does it. It collects metrics with what that endpoint is experiencing periodically. And this allows it to then create some alerts and thresholds and notify the relevant SDN domains that that call is traversing, and allows them then to collect relevant stats and correlate what the endpoint quality metrics are with some network diagnostics, and let us help pinpoint where the potential problem might be. So in this example, it can help us pinpoint where the problem is, but even more powerfully, it can allow us to actually automate some problem resolution. So here, for example, let's say you see where this red X is, that the network is experiencing congestion and that the call quality is impacted because of this. We can now dynamically reroute the call through another service provider without actually even taking the call offline. So now, not just only are we doing automatic problem resolution, we can do things like dynamic traffic engineering to reroute sessions around, say, a network congested point. The document goes into a lot more detail, but I just wanted to provide a little high-level overview of how that works and how this RTM SDN API can provide a lot of visibility to customers and automation and simplification.
Thank you, Manfred. You've proven the point that a picture is worth 1,000 words, and I really appreciate the diagrams you put together, because it really helps explain and simplify a very, very complicated solution. The next question is in the area of endpoints. So we've got the perfect person to speak on that is Monty from Polycom. Can you explain to me what value does RTM SDN bring to endpoints and collaboration applications, especially for mobile endpoints and to the conference controls?
Thanks, Jim. This question is just on time, and I thank very much my previous speakers for laying the groundwork, so my job is made easier on what it really takes to resolve and facilitate good quality of experience on the endpoints. Whether they are mobile endpoints, whether they are static endpoints, and how this facilitation of good quality of experience, which amounts to good network experience as well. So that can actually end up being able to make things easier for the endpoints and almost transparent for the endpoints. So as we go into the discussion on the slide. So on the right-hand side, you can see that there is a call setup that has happened between an endpoint at the bottom and then a wireless endpoint or another video or voice endpoint that might have happened on the right side. So as the path shows, the based on the actions of quality of experience as well as the setup that is provided by UC-SDN to the SDN controllers is making sure that the paths are being able to the kind of resources that are necessary in terms of quality of service enforcements along the way or the flow, as well as the amount of bandwidth that can be reserved along the way of the flow. And Manfred also explained how if there is a error in the path, in one of the segments of the path, that there is a provision to be able to sense that and reroute it, almost transparent to anything that might be visible to the endpoints, without the endpoints themselves being having to do any take actions or report any corrective error, any errors. While at the same time, it is also possible for making it quite seamless for the endpoint. So it is all finally the challenge or this resolution is about the making it easy for the endpoints without really making the endpoints having to do additional work in this space. We will also, just to step back a little bit, once again, take the points about, that Chris had made on the quality of experience and then subsequently on the automated diagnostic services and what it really means to the endpoints that are playing in this space in the voice over IP network or video over IP network. So there is no application as demanding as audio and video. Audio is very sensitive to latency, so any delays or dropped packets that are going to occur in the net as a result of fluctuations in the network are really going to cause a price to be paid. Video also demands not as much as voice does, it also has great demands on bandwidth assurances for good user experiences. So from the standpoint of the IT network administrator, when there is a problem happening, either in terms of degradation in quality of a running session, or in terms of to diagnose or troubleshoot where the problem may have originated, or even a dropped session for that matter. So it needs to figure out whether or not it is the root cause in the degradation is got to do with the device or the headsets and other speaker components that are in the endpoints, or whether it is the network. So the main cause of the problem has stated between the two, and one of the biggest problems or causes is that of the network itself. And once that is separated, it's probably going to be, as we will see subsequently, it is easier for being able to put the narrow down the problem to the device or to the network. And as Manfred also highlighted, it is possible for being able to automate the troubles if they are drilled down to the network and then take corrective actions as necessary. And if it is not possible to provision on the fly any specific remediations that are necessary, then it is incumbent on the part of the network SDN controller to be able to notify the subscribing application, which is where the automated diagnostics issues come into the picture, which provides the ability for the UC application to take remedial action to renegotiate session parameters. The biggest challenges in this cases are the lack of insight into the network status and vice versa. That is, lack of insight into what the network is doing by application, and lack of insight on the network as to what the application has been asking are both eliminated in the being able to provide the QoE by providing the application being able to provide the necessary parameters to the network even before the call is set up. So any limitations in the opportunities for running session to adapt are also eliminated, as we will see in the case of automatic diagnostic services and the traffic engineering as already outlined by Manfred. So all these things are really taking the problem of being able to diagnose as well as provision the main resources on the network away from the burdens of endpoints having to represent this information to the network and seek corrective actions from UC application. So providing these parameters, flow-based network resource control, as was outlined already, and is what RTM SDN does. And these three prime parameters are the ones that are laying the groundwork for the QoE experience. As you can see, the adaptation is in three phases. One is the network assures to the session that the parameters specified by the application are maintained, and if it cannot maintain, there are remedial measures that it can facilitate. And it can also adopt traffic paths as needed, which is one way of facilitating. And if the application may also renegotiate with the customer, so as we already saw. So in the next slide, we will get to see the endpoints terminating. Essentially, it is the endpoints that are terminating the flows and hops. So therefore, the automated diagnostic services are able to provide the device-specific statuses to the UC application. And as Chris and Manfred detailed, the SDN network is able to provide the information to the collaboration service as and when there are network events that are changing it. And these two combine to provide the broader view for correlating the network and the endpoint events for initiating diagnostic services or diagnostics to being able to drill down in a very automated fashion, so that it is possible to build additional applications on top to be able to provide diagnostics and remediations. In the case of endpoints and cloud, the RTM SDN extends the same facility that was originally meant for single domain intra-enterprise scenarios in a fashion that continues to consistently maintain the ease of use and ease of experience that is facilitated by endpoints, regardless of whether they are in the inside the enterprise and eventually to anywhere for nomadic devices that are on the network.
Well, great. You've done a fabulous job of kind of pulling it together based on the previous speeches. There is one area left that we want to get into, and that's in the way of security. So, Shamu from Sonus, what are the security challenges in today's networks, and how does RTM SDN address this?
Sure, that's a very good question, right? Any service, if it is not secured, it's a problem for anybody, right? You can't have the trust, right? So the security is something which cuts across all the components in the solution. That includes the endpoints, your UC system, IP infrastructure, all the middle boxes like firewalls, SBCs, and their interfaces, right? Also the user patterns, right? What user does, what user behavior is. And if you have any component which is compromised, then whole security chain is broken, right? So you have to, and so that's why all the enterprises are very conscious of security, and they want to make sure they are not vulnerable, right? If you look at the security, right, you need to think through, what's the security architecture? All the interfaces are authenticated, the authorizations are in place, the information is exposed based on the authorizations and privileges of the peer. Interfaces and information is encrypted, ensuring the privacy and the data confidentiality. You are not exposing the information to the stakeholders who are not supposed to see the information, and the DOS aspects of it, right? You're not open to attacks from the malicious users in there. Now, if you look at the macro security architecture, right? The RTM SDN or the UC service uses the underlying internet for the transport, and which is again the federated model, wherein there are disparate domains, the enterprises and the IP service providers and the UC service providers, which come together and provide the service. Now, for the SDN, RTM SDN to work through this disparate pieces of network, there are there is a coordination needed, there is a federation needed, and that's where this RTM SDN API and the use cases comes into play. It enables the UC application, which is sitting in the data center, to get the visibility in the diagnostic information from the users in the enterprises and the session border controllers, which are the middle boxes in the network, and collate all the information and then provision the flows across the various pieces of the network, right? Now, because there is a information flow which is happening across the borders through the enterprises and the IP service providers and the data center, the RTM service, you need to make sure that the privacy is not getting compromised. So you have to strike a very fine balance between exposing the right amount of information for doing the diagnostics, at the same time making sure privacy or the data security is not breached, right? And so that is something which is done in the API, right? That's where the real-time firewalls like session border controllers come into play as well. You want to do the topology hiding if you don't want to expose the whole topology within your enterprise to outside network or the service providers or even the RTM application provider, right? Then what you want to do is you can have a session border controller in there, and you can hide the topology. And you want the session border controller to be able to hide your topology at the same time, share the relevant diagnostic information using the RTM SDN API towards the RTM application, so that all the diagnostics and QoS reservation, all those things work fine. At the same time, you're not exposing your network, you're not exposing the topology, you have your own protection against any malicious attack which can come through the common internet infrastructure. So that's a way of addressing the security challenges for the enterprises in the RTM SDN model.
Well, thanks so much. I mean, that is extremely helpful, and we all know that the security is a big issue that everyone's going to have, so I appreciate that. Well, we've come to the end, and now we have questions. We will be turning on your microphone so that you can ask questions, and while you're preparing to do that, let me just start with a simple question. Well, not a simple question, but a question that I think is important is, how is this supposed to work when the signaling and media traffic is encrypted end-to-end?
Why don't I take that? That's an excellent question and something I've heard a lot of customers asking about. And it's starting to become pretty common for UC&C applications to be encrypted by default. And as you're starting to run over a public network, you have to encrypt your media and your signaling for security reasons, confidentiality reasons. In the past, the network used to do a lot of things like DPI and try to inspect the traffic and infer what's going on. What we're doing here is very, very different. When the endpoints talk to the RTM application and set up the signaling, the application knows what port numbers, what IP addresses are being used. And even if things are not being used, because it's coordinating between the multiple domains, it knows how the mapping of those flows go end to end. And so when it sends out the create session or update session call, when sessions are modified, the appropriate SDN controllers know all the individual flows. It knows the end tuple, it knows the IP addresses, it knows the port numbers, it knows the bandwidth needs. So it knows all the attributes that the application is requesting and knows how they're correlated. So even if a call has a video, a voice call, or a multi-party call where there's multiple different streams, it knows that these independent sessions belong to the same session and can appropriately provide use classification to provide the right QE markings and the right admission control to make sure that the entire session is protected appropriately.
Well, thanks. And that's begging another question. And again, I'm not trying to hog this, but I want to make sure we get some important issues discussed. So how do we ensure that this doesn't compromise security and privacy across so many domains?
I can take that one, Jim.
Thank you.
In the case of flows, as Manfred rightly pointed out, we have the 5 tuples, and the 5 tuples are providing the guidance for providing the necessary QoE resources, whether it is QoS, bandwidth allocation, or any required traffic engineering that requires rerouting. So in that sense, any protection that is already provided by way of standard SIP over TLS or HSHA-323 with HSHA-235 or WebRTC with TLS and other protections, as well as the media which takes SRTP, for example. In all these cases, it is the 5 tuples that are already there for being able to provide the right kind of routing and characteristics for or identifying the flow. So, but the payloads are protected, as well as any other parameters that are really required to be done are all protected, and there are no changes for that at all. So whether they are encrypted or secured packets or otherwise, the security is not compromised in any way. It is just about the same type of same flow. It's just that the flow is provided assurances in the network for these 3 resources, such as the bandwidth engineering as well as the quality of service.
And then I'd like to add something else on top of that. In addition, what Manny said, which was spot on, is the diagnostic reporting we provide. We need to make sure that we only provide, say, the diagnostics for a given flow for networks where those flows actually go through, and only to end users that are part of that flow. So that's an important extension that we're adding to the cloud-based SDN model to make sure when we're sending diagnostic records that only appropriate SDN domain receives that. Otherwise, we could be giving off, call detail records to the wrong parties, which is definitely not something you want to be doing.
Great. Well, thanks for that. Anybody in the audience have a question?
So it's Andy here. I'm trying to understand how enterprise firewalls impact here. You say you need to be able to map the flow basically end to end. So that involves, the fact that the enterprise firewall or NAT changes the IP address. Does it require the SDN controller, whatever, to talk to the enterprise firewall, or what sort of protocols does it use to do that?
So there are 2 kind of flows or traffics over here, right? There is a signaling flow, which is more of a single channel fixed port, right? So you can have a HTTP port rule set up in the firewall, which is statically or a priori known. So that capability exists in the traditional firewall. Then there is media flows which are dynamically set up, and only the devices who are aware of the sessions, right? The normal common enterprise firewalls are not aware. They cannot dynamically open or close their ports. And that's where the session border controllers come in. So if you want to protect the whole port range dynamically, you will have to deploy the session border controllers, or you open the whole range a priori by knowing that media is going to be in the range of, say, 20,000 to 40,000 ports. Then you open that for the UDP. So the real-time media does impact the firewall configurations. For the security of the real-time media, the session border controllers are the firewalls for the real-time media, because they are aware of what is going on in the audio, video, which ports the sessions are getting set up, and they can dynamically close and open the ports.
Okay, so the SDN controller would talk to the SBC?
Yes, so there would be interface between the SBCs and the SDN controllers, not the SDN controllers and the UC applications, right? It will feed in the translation, what's happening on the session, to the UC application, and then through the UC applications, it will get the flows will get fed into the whole IP network by SDN controllers.
So I guess I could add just a little more onto that for clarity. That was a very, very good question, by the way. So the requirement is if you have an SBC, it should talk to the RTM SDN application. It will get that information. It does not need to talk to the SDN controllers, but over time we expect that SDN controllers will start talking to the SBCs as well and provide enhanced level of security for that as well. That way you can have some administrative policies of things that might in the past have gone through that won't even be allowed. Hopefully that clarifies that.
Yeah, I think it helps. I might need to do a bit of research, but it certainly helps me. I guess one side question to that is you talk about SBCs. What's the dependencies here on the actual signaling protocols being used? Is there any dependency on it being SIP, or does it apply equally to WebRTC deployments?
So it could apply to the SIP or WebRTC. It's really whatever signaling you are using, right? And you need to be able to protect that. So you'll have to pick what is the UC infrastructure. It really flows from there, right? What is your UC application, what signaling it is using, and how it is able to communicate, right? What is the SPC or the real-time firewall, which is protecting the traffic.
So, Andy, this is Chris. If you don't mind, let me expand on that. As Shambhu said, it really is independent of the signaling protocol being used, because if you get to the details of what we've done with the specification around automating QoE and automating diagnostics, we've defined effectively an information model and an associated API that let UC applications communicate with the network, right? So the assumption is that the UC application itself is the one that handles all the signaling traffic using whatever signaling protocol it uses. Could be SIP, could be WebRTC, could be H323. So there's a variety of signaling protocols that could be used. But based on that signaling protocol, the UC application establishes information about what needs to happen to the network, and then it uses the RTM SDN API and the associated information models to communicate its requests to the network. So what we've done in terms of APIs and information models is completely independent of signaling protocols being used at the application level.
Okay, thank you. Yeah, that's the answer I hoped for, so thank you.
And then, by the way, if you don't mind, I'll loop back to your earlier question, which was absolutely a very good question. So Shambhu gave the answer of how the SBC is involved. Now, typically, the SBC is the entity that protects the service provider network, meaning the provider of the UC or RTM infrastructure. Now, there's a second entity, and I'm suspecting that that's the one you're referring to, which is the firewall that actually protects the enterprise network from the access network that's being used to access the cloud infrastructure. So there's, in an end-to-end configuration, you typically have an SBC on the service provider side, and you have a firewall on the enterprise side.
Yeah.
Now, that firewall is typically configured statically to allow outgoing RTP media connections, and none of that has to change. So everything we're doing will assume that that will stay in place, doesn't get affected, no need for communication between the UC application, the RTM SDN infrastructure, and that firewall. That said, the interfaces we're providing and the information models we're building are designed to let UC applications or RTM applications communicate with the network to make the network better aware of what's going on at the application layer. So it's fully expected and anticipated that over time, there might be value in having the RTM applications or the UC applications actually communicate with a firewall to make it aware of what needs to happen, and have firewall ports being opened and closed dynamically based on actual traffic rather than on predefined rules. So that is not something we're doing in any work items today, but the vision of RTM SDN fully anticipates that, because in the end, if you think about it, what we're doing is providing a communication layer between applications and the network. And the network could involve switches, routers, but it could also involve middle boxes like firewalls and whatever else. So long term, absolutely, there's an opportunity, I think, to extend NAT firewalls with communication interfaces to the application so that they can be even more secure.
So Chris, I would like to add a point in here, right? So that's right. On the service provider side, you have the SBC. On the enterprise also, you will have the SBC. And there are a lot of enterprises which have the enterprise SBC. So they secure their own UC infrastructure or the endpoints or the infrastructure from external attacks. So the SBC exists on both the ends. It's really the edge border security, right? the enterprises protect their own border. It's managed by the enterprises. Service provider protect their own border. So SPC exists at both the places. And if you want, it's really about whether statically opening the port ranges like 20,000 to 40,000 in order to allow the 10,000 voice calls or video calls to continue is secure enough for the enterprise, or they want all the ports to be closed until unless there is a well-known session which is being established. Once voice call is established, then only that port opens. If they want that level of security, then enterprises deploy the SPC today.
Yeah, that's sort of where my question was coming from, because from a WebRTC perspective, for instance, there would be no SPC in the enterprise, but there might be something else in future. I guess there might be an enterprise turn server or something.
Right. So you could have the SPCs, right, in the enterprises, right? It's really about what is your signaling protocol, right? From the UC perspective, say there is a basic signaling happening, right, between the endpoints, WebRTC endpoints, and your WebRTC infrastructure, which is in the cloud, right? And then that WebRTC infrastructure server that needs to bring in what is your the firewall or the SPC in the loop, so that media can flow through it, right? It can do the net traversal, it can do the security, the port range. So you need to have some way of bringing that. What the signaling protocol could be, that could be SIP. So that's one way it could work, right? The second way is that I think that's where the Chris and Manfred was trying to suggest. The UC infrastructure feeds into the RTM SDN controller, and then SDN controller provisions those flows on the security device or the SPC, that there is a WebRTC flow which is going out from the WebRTC endpoint inside the enterprise to somewhere outside on the internet. And please open the port X to port Y communication, and that's when the SBC or real-time media firewall would open that port dynamically, right? So those are the two models, right? And as Manfred and Chris were saying, that second model is still not very mature enough, right? We are still that is still in the thinking, but the first one should work today.
Just to add to that, I just wanted to briefly say that you can consider the SBC as the traditional way of providing the edge configuration or the edge application firewall, both as a B2B UA. It could be a return server in the case of, the functionality could manifest as a return server in the case of WebRTC, for example.
Yeah, it's more about the real-time firewall, right?
Well, with no more questions, I'd like to thank the panel. You've done a fabulous job of describing a very complicated solution, but a very valuable and worthwhile solution, particularly as we move forward. We know we're going to have a lot of opportunities, and I look forward to working with you gentlemen again and helping explain this to the audience and to the prospects out there who are looking for this. And again, here is a list of sources of information that can help you on your next step. Thank you all, and again, thanks gentlemen for joining this panel today.